Section 12.9a is about solving rational equations. Now, a rational equation is an equation that has irrational expressions. So what we're going to add is the equal sign. In all of Chapter 12, we've been doing expressions that didn't have equal signs. So now we're going to add the equal sign and make it an equation, and that's going to change things slightly. An example like this one, where you have one fraction on the left and one fraction on the right, that's also like a proportion. So in this case, we can solve this like we used to solve proportions by cross multiplying. So 12 times x plus 2, and then over here we'll multiply across, put the equal sign in the middle, 4 times x plus 5. Please don't forget to distribute. So 12x plus 24 and 4x plus 20. And now just simplify this, move the smaller coefficient by subtracting the 4x. Now throw the party or do PEMDAS in reverse, subtract the 24. So 8x equals negative 4, and then divide by 8. We're going to reduce that fraction to negative 1/2. Now in this example, we can't use cross multiplication because it's not just one fraction equals another. There's a big rational expression involved here. And I want to talk to you about the difference between solving when there is not an equal sign and solving when there is. In the past, when we did not have an equal sign, our goal was to get common denominators and then add everything together or subtract. But now when we have an equal sign, we actually want to find the common denominator and then use it to get rid of the fractions. Let me show you what I mean. We're going to go over here and find the LCD. And remember, the LCD says take the fractions, and we're going to take every factor the maximum number of times that it appears. So here's 1n, no n's, and 1n. So I'm going to take a single n. And then here's an n minus 6 that I'm also going to multiply by. So there's my least common denominator, n times n minus 6. Now what am I going to do with that? Instead of getting common denominators and adding and subtracting everything, I'm going to take that and multiply it by every term. Now this can get messy if you're not careful. So I'm multiplying n times n minus 6 by every term. Now watch what happens. This is actually very good because I have an n on the top, an n factor, and an n factor on the bottom. I can cancel them. So what does it leave me? It leaves me with an n minus 2 times an n minus 6 that I will simplify here in a little bit, but I don't have a fraction anymore, which is a good thing. Now I have an n minus 6 factor on the top of this, an n minus 6 factor on the bottom, so I cancel those, leaving me with a minus n times n minus 3. Again, a little complicated, we'll deal with it in a minute, but there is no fraction. And then over here, the n's will cancel, a factor of n on the top, a factor of n on the bottom, leaving me with just an n minus 6. That idea is the idea of getting rid of all the fractions when you have this equal sign. And I suggest you do that. You find the LCD, you multiply every term by the LCD, and now we'll simplify and finish. So we'll FOIL this out. N squared minus 6n minus 2n plus 12. Distribute the negative n, so negative n squared plus 3n. Now we'll collect like terms. I have an n squared here minus an n squared on the same side, so they're gone. 1n squared minus n squared is nothing. I have negative 6n, negative 2n, and 3n. So that's a negative 8 plus 3 is negative 5n. Then I have a plus 12, and that equals n minus 6. Move the one with the smaller coefficient of negative 5, so I'm going to add 5n to both sides. So we're going to get 12 equals 6n minus 6. We'll add the 6. So 18 equals 6n, and then divide by 6. So it looks like n equals 3. Here's another example of a rational equation. Remember what we're going to try to do. We'll find the least common denominator. So we take every factor in the denominators the maximum number of times. So I see an a, and then I see another factor of an a plus 1. So I have to take those And now because there's an equal sign, I want to get rid of all the fractions, and I do that by multiplying by the LCD. So multiply every term by a times a plus 1, a times a plus 1, and even this one over here, a times a plus 1. A plus 1's cancel top and bottom, leaving me with a negative 4 times a. Second term, the a's cancel, leaving me with a 3 times a plus 1. Now, if you don't mind, I'm going to distribute that 3a, or distribute the 3 to the a plus 1, leaving me 3a plus 3. And then over here, I'll distribute this a also, giving me a squared plus a. So I not only got rid of the fractions, I distributed where necessary, and it made my equation a lot simpler because it doesn't have fractions. Like terms on the same side here, so negative a plus 3 equals a squared plus a. Now I see this a squared here, which means I'm probably going to have either a binomial or a trinomial. So I'm going to bring everything over by adding a and subtracting 3, setting it equal to 0. So a squared plus 2a minus 3. There's that trinomial I was expecting. Now I'm going to use the diamond. Two factors of negative 3 that add to be 2 are positive 3 and negative 1. If I set each one of those equal to 0, I get an answer of negative 3 and positive 1. Those will be my two solutions. Here's our last example in section A. If you think you're up for it, pause the video and try it on your own. I'm looking for an LCD, so I take any factor the maximum number of times. I see a k, so I take a k. I see a k plus 1. One on the right here, one on the left. I don't combine them and give me two of them. I just take the maximum number. So I'll multiply each term by the common denominator, kk plus 1. I see a k plus 1 on top cancels, leaving me a 5k. K's cancel. All right, now understand this, negative 7, and then distribute. So negative 7k minus 7. K plus 1s are gone, which equals k. So this won't be too bad here. Like terms on the same side, negative 2k plus 7 equals k. So I'm going to add 2k, move the smaller coefficient. So 7 equals 3k. Then divide by 3, so k equals 7/3. But I notice as I'm doing this that this should have been negative here. So I'm going to change that to a minus. And that's also going to change this to a negative. So my answer then is going to be negative 7/3.